Okay. Hi, everyone. I'm Allison. I work on the search retrieval team here at Depop.
Hi everyone, I'm Hamza. I'm a backend engineer for the search retrieval team.
So just a quick intro for those of you who might not know. So Depop is a two-sided marketplace, and currently we're the fastest growing resale fashion player in the US. So today, myself and Hamza are going to talk a little bit about our search personalization journey and some of the challenges that we had. What am I think I've Oh, is it this button?
Yeah.
Okay, thanks. So first of all, there's quite a few unique aspects about working at Depop that makes working on search extra fun. So as I mentioned before, we are a two-sided marketplace. So this means that all of our listings are user-generated, so everything is one of one. This also means that our inventory is unique. So once an item is sold, that's it, it's gone forever. So that means we don't have a lot of product history that some other large retailers might use to train their models. But what we do have instead is a very active user base, a whole host of listings, and a lot of interaction data that we can use to learn more about our users' tastes and preferences. And because Depop is all about style and discovery, we think that personalization is our key differentiator in this space. So because of the large amount of browsing data we have, this has allowed our wonderful recommendations team here at Depop to build strong user representations of our users' taste. And this forms a core part of the recommendation system here at Depop. So we also wanted to see if we could also use them in search. So at a very high level, it's a two-tower encoder. We have user and product embeddings that are jointly learned together. So whilst this feature makes it great for recommendations, and it's one of the reasons why our recommendations are so unique and diverse and why our users like them so much, it also adds a bit of operational complexity. So currently, as the embeddings are learned at training time, this means that in order to get new embeddings for new products or new users, it requires the model to be retrained. And as this shifts the product and the user embedding space, it means that the embeddings are not backwards compatible. So every time we retrain the model, both the user and product embeddings need to be re-indexed. And currently we retrain this every 6 hours. Now I'll talk through a little bit about our search workflow here at Depop. So here at Depop, we use a multi-source two-pass retrieval search system. So as you can see from the funnel diagram, first we have over 50 million listings. And then we have a matching layer where we use lexical and semantic search in order to narrow this down to tens of thousands. And then we have a pre-ranking or selection stage where we narrow it even further into thousands. And finally, we send our final candidates off to our ranking team, who use a light GBM model to optimize this for more downstream metrics like purchase conversion rate, user engagement, those kind of things. So currently, the way we have introduced personalization to search is we've added it into this pre-ranking and selection stage. So here on the search retrieval team here at Depop, we play primarily in this matching and pre-ranking stage, and this is also hosted in OpenSearch. So what we have done here is, as part of this layer, we've introduced the user and the product vector embeddings, and we calculate the similarity between them. So in this way, we're kind of shifting the candidates a bit closer towards our users' tastes. So next, I'll pass on to Hamza, who'll talk about the engineering part.
Thanks, Allison. So at this stage, we knew we wanted to use our user and product embeddings from Rex to better personalize search. But the big question was, how do we actually integrate them into the search pipeline? We approached this by introducing a new retrieval source, one that combined our existing keyword-based retrieval with vector ranking using OpenSearch's Spice engine. This worked by first filtering products with keyword query matching, and then ranking those filtered products based on their proximity to the user embedding. So we can see that illustrated with the diagram on the right. You can see in the first graph, this is a representation of the whole inventory. And then after the keyword matching phase, we're left with just the red dots. And then in the resultant embedding space, we rank these products based on how close they are in distance to the user embedding. Or in other words, how closely they align with the user's personal preferences and tastes. One thing I want to mention here is that our two retrieval sources, they both surface the exact same products. There's no difference in what's being returned. The only difference is in how they are ranked. So with our keyword relevance query, products are ranked using BM25 and other custom signals such as recency. Whereas with a personalized source, products are ranked purely based on vector similarity. So at search time, we fire both of these two sources in parallel, and then we mix the search results in a 50-50 ratio to form our candidate set before they are re-ranked. So in summary, that's our read side approach, but we faced a number of engineering challenges associated in building an automated system that handled the frequent model retrains that Allison mentioned. But in the spirit of doing things that don't scale, we decided to run things manually for the first experiment before we validated the concept. What this looked like was every workday, we trigger a job that published the latest product embeddings. We deploy a new SageMaker endpoint. We create a new index, go through our reindex procedure, wait for the reindex to complete, and then finally we deploy a PR to roll over traffic to the new search index and endpoint. All in all, this took around 1 to 2 hours of active dev work per day for 2 weeks, but we got the win. With this feature, we saw a huge uplift in purchasing. And I think we learned two things here. First, that we could better personalize our candidate set with this approach in a way that materially increased purchasing. And secondly, and perhaps more importantly, I did not want to be running manual reindexes for the rest of my Depop career. So I mentioned we had several challenges with the frequent model retrains. What are these challenges? First, how to ingest retrain embeddings while serving live traffic. So suppose after a model retrain, we've got a new set of product embeddings that we need to publish. We can't publish these to a field that's currently serving reads because we'll have two sets of embeddings from different model versions, which will lead to garbage results. So these embeddings need to be indexed elsewhere. Second, how to ensure we use user and product embeddings from the same model version. Equally, we need to always ensure that user and product embeddings are always from the same model version. In particular, when we roll over to a new model version, we need to ensure that both user and product embeddings roll over at exactly the same time. And finally, how to detect when all product embeddings are indexed. We can only roll over once we've indexed all of the latest embeddings after a retrain. So we need some sort of mechanism that allows us to determine when this happens. So after we'd validated the concept with the first version, this was all about essentially productionizing the feature and by automating it. So to ingest retrain embeddings, we introduced a blue-green indexing approach. Each model retrain alternates between 2 product embedding fields, blue and green, as you can see, and also 2 corresponding SageMaker endpoints. So every time we want to publish a new set of product embeddings to OpenSearch, we always publish to the non-live field. And equally, we always deploy the latest user embedding model to the non-live SageMaker endpoint. To ensure that user and product embeddings are always from the same model version, we store both the live color and model version in the index metadata, which sort of acts as our source of truth. So on the read path, our search service first fetches the metadata to determine the live color and model version, and then gets the user embedding from the corresponding SageMaker endpoint. So if the metadata has green, it will fetch the user embedding from the green endpoint. And then it'll perform the ANN query with the user embedding referencing the live field, the live product embedding field in the OpenSearch index. So to automate and orchestrate this whole process, we built an Airflow DAG. So this was scheduled to run after every model retrain. The first task, it determines the non-live color. So what it'll do, it will check the index metadata and determine which is the color that's not currently live. Then it'll deploy the latest retrained user embedding model to the non-live SageMaker endpoint. And finally, it'll publish product embeddings to Kafka. Now here, in the Kafka event, we include the color of the field that the downstream Kafka consumer needs to index to. So if blue is the non-live color, in the event, it'll contain blue. And so the downstream consumer knows to index these embeddings to the blue field. We also emit a special last event marker. So with every set of embeddings, we emit this last event. And so when this last event is consumed downstream, it signifies that all of the new product embeddings have been indexed and essentially initiates the rollover by updating the index metadata. Altogether, this system, it solves all of our engineering challenges that I mentioned, enables seamless rollovers following model retrains. And yeah, it's been working quite well for us for the last year. So following this whole automation procedure, we ran another experiment and we saw a small incremental uplift in purchasing compared to the first experiment. I think this difference can probably be explained by the fact that in the first experiment, we weren't doing indexing on the weekends. So we had a couple of days of stale data that we didn't have with this automated solution. So we rolled out this whole system in production, and it was working well. Our next iteration was adjusting the mixing ratio. So I mentioned earlier we had a 50-50 ratio between the personalized and relevant sources, but we explored using different ratios, up to 90% for personalized, down to 25%. But for reasons we don't quite understand, all of these three variants performed exactly the same. We saw no difference in purchasing between any of these variants. To be honest, I think we would have preferred to see a negative result even just for learning purposes. So yeah, if anyone has any theories on why this might be, we'd be happy to hear. So our next iteration after this was essentially increasing the frequency with which we retrain the model. Previously, it was once a day, and we upped that to 4 times a day. The high-level system around how we indexed all of the new embeddings and so on was more or less the same. We just made a few tweaks to account for the more frequent retrains. And this did really well. In particular, we saw a huge uplift in purchasing for new users, which, if you think about it, it makes a bit of sense because with indexing once a day, new users would only be captured up to 24 hours. Whereas with 4 times a day retrains, they'd only have to wait at most 6 hours. So essentially, they're getting personalized results sooner in the Depop journey. Overall, we learned a lot on this project. One of the key challenges that we faced was really high CPU spikes during bulk indexing or product embeddings. Essentially, we were indexing 20-odd million embeddings to a live replicated index in OpenSearch, and we saw huge CPU spikes. So we did a bunch of optimizations. Perhaps the thing that we found most surprising was moving to an index with less read load improved indexing performance. We saw way lower CPU increases with this other index. Secondly, benefits of quantization. We used OpenSearch's scalar quantization. We saw basically no loss in the accuracy of our results with this, but we saw huge gains in performance, especially when combined with SIMD optimized hardware.
And yeah, one of the other unexpected outcomes that we had from this was we saw some cannibalization from purchases from our homepage recommendations. So I guess some of this was to be expected since we're using similar embeddings here, but it was a lot more than we had anticipated. And so just to clarify on this as well, we didn't really see the same impressions in 2 places, but somehow we still seem to be taking purchases from the home feed. So yeah, this is something that we're still trying to figure out.
If you're looking for a change in scenery, reach out to Callum and Adam, wherever he is. Adam's at the back. We've got open roles in both engineering and machine learning. Yeah, open the floor. We want to open the floor to questions and discussion, please.
Thank you. That was a great talk. So do we have any questions for the team?
First of all, thank you for the presentation. I think this was quite detailed and quite interesting. I have a question regarding the slides where you showed the blue-green approach. And so you are saying you are serving the user embedding via SageMaker endpoints, which I didn't really get why, because are you using real-time features to compute the user embeddings, or are they pre-computed every 6 hours? Because yeah, I was under the impression at first that it could be served via a key value store database.
Yeah, so there's no actual inference going on. It's just a preloaded set of user embeddings that we're fetching. Yeah. You want to explain why that?
Hi, thank you for the talk. I don't know whether this would be a stupid question, but can you please talk through why do you have 2 separate retrievers, your relevance retriever and personalized retriever? Why did you not go for a combined method?
So that's actually something that we're exploring as another iteration. So we're looking at ways where can we combine the BM25 score with the personalized score and sort of capture a wider range of products in our like inventory during the matching phase. But I guess, yeah, to be honest, I don't know why we yeah.
Potentially a dumb question here, but you'd mentioned at the start of the presentation that when you introduce new products for your 2-tower model, you'd need to essentially retrain it to re-index and recalibrate the embedding space. How come though, I mean, I guess depends on whether there's a big shift in the feature set, but can't you pre-compute the new embeddings using the existing pre-trained model, or would that just produce gibberish?
Yeah, so this is one of the interesting things about the model and kind of why it works in recommendations. So the model itself is not featureized at all. It's trained purely on product IDs. And we're learning the interactions between different products and users. And we find that we're able to create an embedding space that much better matches the user's taste than if we were restricted by metadata. This is also one of the reasons why our recommendations are so diverse and so interesting as well.
Cool, thank you.
Any further questions?
I mean, generally, this sort of model are trained with purchase signals. And since as you are saying, you don't really have stocks, and once an item is being purchased and it's not available anymore. So what sort of data do you use to train the 2-tower model or item? And I mean, what is the relevancy signals that you use, basically?
Yes, that is also a good question. I don't really know the answer to that right now, but we have some wonderful people from our recommendations team who can help you with that.
Any of them in the room?
Yeah, some mingling in the room.
The training data is views, and we actually don't use the purchasing signal because we try to not be too transactional with the recommendations and leave the ranker to do that. So our first pass is like engagement optimized, so trained on views.
I have a question myself, actually. The A/B test not showing any difference between a blend of relevance and personalized results. I mean, that confuses me, as I'm sure it can confuse you. But are the personalized results just generated by the embeddings, or are they already relevant because you've done a search in the first place?
So we need some way of like filtering down the inventory to something like a subset of products that we can actually rank by personalization. And so we use the keyword query from our relevance query. And so yes, the answer is that they are relevant to some extent because they're matching using standard text matching, but the ranking doesn't take into account things like BM25 or anything like that. It's just purely to whittle down the products to those that are roughly in the pool of matching what the query intent is about.
So that they match the query, but they're not ranked in any way by relevance. They're just a big lump of products that you're then going to use in the next stage.
Yeah, exactly.
Okay.
We could have, we just happened to use our keyword for query matching. Equally, we could have just done a bunch of filters, done a more simplistic query matching phase, but we just decided to use our keyword query matching, one-to-one.
Okay, thank you.
Yeah. Can you hear me? Okay, great. Sorry, I know I walked in late, so this might seem redundant, and if it is, I apologize. I was having a look at your model, and one of the things that stood out to me was that it's very similar to other search engines like Fear. But the main problem with this is scaling, as inventory is sort of a problem. How are you guys dealing with that, particularly if it deals with like a specific product ID?
Does anyone from Depop know? Basically, the folks that actually built the model, it's not within the remit of our team. So yeah.
No, I think you get extra points for stumping them. I think that. Any further questions? Your third question, sir, but well done.
I'm not spying, I swear. So yeah, I was also I was wondering, but just a question, if you, because yeah, I guess one of your issue is the cold start problem and the fact that you are dealing with product ID as a key of embeddings for products. And do you have any idea or lead on how you, I mean, if you, are you planning to try to solve this problem? And if yes, do you have any idea?
Yeah, so I guess one of the limitations of the model is that we do have a cold start problem because we rely on users having like enough interactions, products having enough interactions. I'm not 100% sure if the Rex team are looking into this, but it could be coming up.
Does the cold start problem go away the more often you're retraining?
So because we still need users to have like a minimum number of interaction threshold, it means that if you're a completely new user, then you essentially won't get any recommendations.
Yeah, one thing we're doing at the moment to try and solve that, instead of lowering the thresholds for eligibility into this kind of like these recommendations, is to use more reactive signals as they browse. So once you log into Depop, you won't have these recs, but we'll know, oh, you've seen a few products and things like that. So then we can use other recommendations engines based on products to say, okay, well, you might like these kinds of things. So that's kind of one of the things we're looking at the moment, rather than trying to bring that threshold for eligibility down. But it's kind of an active area that we're looking into.
Thank you. Right. Oh, one more question.
Hi, thank you again for the talk. Bit of a more general query regarding the embedding data set, the embeddings data set that you're using. As a lot of other, consumer-oriented platforms pivot towards NLP-focused search algorithms that take in more context as opposed to just lexical ranking and keyword matching. Are you guys on the search team thinking about that, and how is the future of Depop search going to include potentially shift towards to that kind of angle of searching, and how would your data set be used in that case?
Yeah, so I guess at the moment, we are currently working on developing and improving upon our semantic search. So we're currently developing a new query embedding model where I guess quite similarly to this one, where except instead of users, we're training on like the queries and the product interactions. But yeah, that's all something we're developing.
Hi, thank you for the presentation. I wanted to ask, how does your model capture like short versus long-term interests?
That's a good question. I don't think I'll be able to answer that, but I'm sure if you speak to someone around here, maybe after the talk, that they can help you.
Yeah, I do appreciate that there are two people up here giving the presentation. There are other Depop people here. If you'd like to, all the Depop people, put your hands up. Excellent. So you now know who to go and harass with that, later, who to go and ask. Okay, that was a great talk. Thank you, please, both our presenters. Okay, we're going to have another quick break so you can get to know people a bit more. Again, go and ask the rest of the Depop team if you still have burning questions. We'll be back here in 10 minutes for our next talk.